Hey, how's it going? It's Keith Townsend from the CTOadvisor.com. And today is T-shirts day, Ed. But for somehow, I get the impression that at ONS in general, T-shirt day is every day for you.
It's pretty much every day for me everywhere.
So Ed, introduce yourself to the CTO Advisor audience.
Absolutely. My name is Ed Warnicke. I am the Technical Steering Committee Chair at the FDIO project, the FIDO project. We make the world's fastest pure user space data plane. We can route over a terabit per second of traffic on a commodity server with millions of routes on the routing table. And we're here today to talk about
The word cloud native and where this ability. So even, I've been following DPDK for a while, and this whole concept of using x86 hardware to do data transfer, data management, data services in general. We're at ONS. So we're talking about using open source software to accelerate the network, provide white box type of services. But then there's this other conversation about cloud native that, on stage, we kind of had the CNCF guys, we had the guys from the various projects, and there seems to be kind of, we should be working together, but not quite sure where that's all at. Help fill us in.
So I find the easiest way to understand what's happening both in cloud native, but also in the attempt to move from NFV to cloud native NFV, is to sort of look at the two stages we went through in getting to cloud native. Right. So in the beginning, we had physical servers.
Mm-hmm.
Then we went to virtual machines. And when we made that transition to sort of cloud 1.0,
right,
we took every physical thing in the universe and we slapped a V in front of it and we called it good. And one of the things we learned in that process is this was a terrible idea.
Yes.
Because many of the things that were physical were actually anti-patterns in the cloud.
So I got into this rabbit hole with VMware when we were talking about NSX. And I got to the point where I'm like, the concept of a virtual switch makes no sense. If we're talking about abstracted software, why do I need to replicate this physical concept of ports and virtual switches and all of that in a abstracted world?
No, you don't. It was the lust to put V in front of everything you saw that led to that problem. I mean, obviously, at the end of the day, something under the covers has got to do those activities.
Exactly.
But there's no reason you would ever want to know that if you were an app developer.
Exactly.
Right? I had an interesting talk that I gave at Open Source Summit where we had about 500 people in the audience. And most of them were DevOps people, and I was getting a lot of feedback from them as to things that they thought. And one of the questions was, how many of you ever want to know that a subnet exists again? And the answer was no one. Not a single
There's no good, from an application perspective, looking at it from the application world, there's no good reason to know that. I mean, there's probably still a need for subnet because we're going to still use IPv4.
Oh, the mechanics are still there.
They're still there, but why should an application developer want to know that I can't have access to layer 2 because it doesn't exist in this environment? It's irrelevant.
Who in the cloud cares about layer 2, right? Everything you care about is at IP and above.
Exactly.
Right? So, and this is where Kubernetes, when we made the jump to Cloud 2.0 with Cloud Native, really got it right. Because it turns out that app developers care about two things.
Mm-hmm.
What I call reachability and isolation, meaning everybody can talk to everybody unless you isolate some workloads and limit who can talk to them.
Exactly.
Right? And the second one is service discovery and service routing, which is my pod wants some service from someone. How do you get it? How do you figure out how to get it? How do you get there? Right? Those are the only things you care about. So literally in the Kubernetes API, there is no concept of an interface. There's no concept of a subnet. The concepts you have are in terms of these two things.
Which is great from an application developer's perspective. where I think this is where this starts to break is when if I've created NFV products and projects and I look at Kubernetes and think, man, this platform would be perfect for me to abstract away NFV and these network functions. I can stop calling them virtualization, but these network functions. I only have these two concepts to work with.
Well, so here's the thing you got to think about when you do this, right?
Okay.
So the first thing is I actually call them CNFs, cloud native network functions.
Okay.
And being cloud native is more than just being containerized, although that's an important part of it.
Mm-hmm.
Because one of the things you have to realize is that in cloud native, your unit of deployment is not a container; it's a pod.
Exactly.
And a pod can have more than one container in it, but it's the single network and storage context that are provided to those containers. So that's why I use cloud native instead of container when talking about CNFs.
So, and let me make sure I understand that. So, the concept of a pod, regardless of the underlying compute, is where my boundary is drawn from a network perspective.
That's what your workload is. It gets a single networking context, a single storage context.
So, whether we're talking about service, functions as a service, serverless, functions as a service, containers, whatever the concept, pod is my identifier.
Exactly. So, but as we make this transition, then we have a couple of things we have to do that are kind of interesting from the point of view of someone coming from NFV. So, for example, if you want to process packets in a CNF, which is what the entire game is about,
right?
You can't do that anymore with magic plugins to the kernel because you don't have your own kernel.
Right, I don't have access to the kernel. I can't do, if I take, I listen to the Intel and Cisco guys, and the simple concept that we have in virtualization or process pin. I can pin a process to, and this is going different topic a little bit, but I can pin a process to a core and take advantage of VPPK. However, in Kubernetes, all of that is abstracted away from you.
Well, so it is, but there are some intelligent things that are being done on some of these things around cores and NUMA. There's a lot of good work that's going on that is managing to do them in a way that meshes with the simplicity of the overall model. But the sort of really interesting thing when you move to CNFs in terms of this is you suddenly have to put your entire data plane in user space. Right? And that's a big jump from where we are right now.
Yes.
Now, the good news is we have the tools to do this, right? So in FIDO, we have a project called VPP. This is the thing that will route a terabit per second of traffic on a commodity server.
Which is It's
a crazy number. But it also will do all of these sorts of all singing, all dancing networking things you want to do. All the kinds of things you need to actually do to build a VNF in terms of supported protocols, GTP, MPLS, IP, IPv6, segment routing, all the things that no one has heard about in Cloud Native and doesn't want to. Right? But if you're writing a CNF, you need those.
Exactly.
And it has a plugin architecture that will allow you to plug in whatever it is you need that it doesn't have. The result is this becomes sort of the best building block for building your data plane CNFs, and we've seen that with some of the use cases going on in ONAP where they literally took, for some of those use cases, VPP and ran it there as, in that case, a VNF. They're running it at a VM. But the same technology then just immediately drops into a container for CNF.
Okay, so these constructs and plugins are being created in order to bridge that gap.
Absolutely.
So it doesn't sound like we're as far away as I initially thought before I came to the show. Because I looked at Kubernetes and I'm thinking, I don't see the connection. But a lot of the good work is being done.
Yeah, absolutely. And there's a nice relationship between VPP and TPDK because TPDK does a job that we call network I/O, which is it gets a packet from a NIC or a VNIC onto a thread on a core. It does that brilliantly, and somebody's got to, right? And what VPP does is it does all the routing and switching and everything else.
So the intelligence.
All the intelligence, exactly. And so they end up working hand in hand. But that's the piece about how you actually get the workload working there. The second piece is, okay, now that it's sitting there, how do I allow it to interact with the rest of the CNFs in the system? And sometimes even physical boxes providing network functions. And this really gets to the, how do I make the conceptual leap from Cloud 1.0 when we were doing NFV, where we just put a V in front of every physical thing.
Right.
What are the Cloud 2.0 constructs that we really want for NFV? And I would maintain that at the very highest level, they're actually the same constructs that the app guys want. We want reachability and isolation.
Right.
We want network service discovery and routing.
And so this is something that I've been noodling when it comes to Kubernetes, for example. One of the big pushes or potentials of Kubernetes is cross-cloud or multi-cloud implementations. And one of the things that jumps out to me immediately is this network service piece, which says, you know what, I may not care about QoS, quality of service, but I most definitely care about class of service. I want to know what the latency is from one pod to another pod. I want to know what the overall bandwidth is, so that when I place workloads, when I have Kubernetes automatically place workloads, I can give that information from an application perspective, those requirements, and then Kubernetes could intelligently make those decisions on my behalf. Where are we at in kind of that network services discovery?
So in terms of placement of workloads, so there are two ways when I think about bandwidth, latency, and the sort of boss sort of stuff, the class of service, quality of service. there's sort of two pieces I think about. The first is getting resources from the actual node you're running on,
Right.
right? So, for example, I have a 25 gig NIC going into the node. Have we overcommitted or not?
At that physical lowest level.
Exactly. And the same. So I think about that, and then I will also think in terms of latency about, okay, you can actually with Kubernetes influence the affinity of pods to cause some pods to prefer to deploy on the same node with each other.
Right.
And so for certain CNFs, you might want to do that because if they're on the same node, we have tools in VPP for allowing you to get ultra-fast cross-connects and ultra-low latency cross-connects. So for example, we have something called MEMIF that will literally let you run essentially a shared memory link between two CNFs so that your bandwidth and latency is the bandwidth and latency of the memory bus, which is better than anything else you're going to get.
Right.
So those sorts of things I think are evolving reasonably. The constructs in Kubernetes for dealing with them are fairly, they're not there yet, but you can sort of see the sketches of where they're going to go.
Okay.
The harder problems are the general case you talked about. I need this much bandwidth between this pod and that pod when they're not on the same box. Because then you have the physical network in between and the need to interact with that to be able to assess what's available and to be able to get whatever guarantees it is that you need from the physical network. And that's true whether you're talking about the bandwidth that you need or the latency that you need.
Exactly.
Because lots of stuff can happen between this server and that server.
And especially as we start to abstract away the whole concept of networking from everyone. I mean, I've looked at network projects where the abstraction is like create this abstraction on top of abstraction on top of abstraction. And at some point, you're like, I don't know what carrier I'm running on. I don't know what the underlying technology, which I really don't care.
Yeah.
All I want to reachability is all I really care about. Can I reach from one workload to another workload? And now this concept of cost, can I reach it in the reasonable amount of time that my application is performing?
Absolutely. And some of the workloads that we have in NFV are very latency sensitive.
Right.
Right? And by definition, they're pushing an enormous amount of bandwidth because we are wanting to run real network traffic through them. It's not like the app guys who, they have definitely, when you get to the video guys, they have real serious demands.
Exactly.
But your run-of-the-mill microservice doesn't drive a huge amount of traffic.
Exactly. So I really enjoyed the conversation. Filled in a lot of little crevices in my knowledge. I really appreciate it. And if anybody wanted to follow you on the socials, do you do social media?
I do. So I'm under the extremely counterintuitive @EdWarnicki on Twitter. So if you can just keep that clearly in your mind, you should be able to find me.
All right. And if people want to find out more about the FIDO project, where can they go?
Go to fd.io, and you will be able to get from there. Or if you're a developer, go to wiki.fd.io, because that's where everything is. And as with most wikis, the good news is anything you want to know is on the wiki. The bad news is anything you want to know is on the wiki.
Well, that's it for this episode of the CTO Dose. If you want to find more CTO Dose, go to ctodose.com or follow this YouTube channel. Talk to you next CTO Dose. Thanks a lot for following the coverage at ONS 2018.